Hi everyone, welcome to the Transformerless power supply. So if we run it over here, we have 220 volts producing 4.8 roughly DC voltage. So I'm going to show you how to design the schematic diagram that I've already designed. It's pretty simple. I'm using PROTEUS 8. Yeah, let's get into it. So this project all starts with a AC power supply, which when we search it is V sign. I already had it from the previous schematic, so I'm just gonna place it right over here, and we need to measure the voltage that comes out of it. So we go into the AC voltmeter, we're gonna place it right behind it, and we're gonna try connect the two. And if you play or run the simulation right now, it's gonna show 0 volts. That's because we never set the frequencies nor the amplitude of it. So if you go to properties of the V sign, you can change the frequencies to 50 Hertz. You change the amplitude to 220 volts. And if you run it again, it's gonna show roughly 155, 156, which means that there's an error in the app. I don't know what happens for it to do that. So we can just stop the program, go to properties again, keep the frequency at 50 but the amplitude at 310 or 320. Let me do 320 first. Let's run the program and see how much 320 goes for. A bit too high, so I'm gonna stop it. I'm gonna change it back to 310, see how 310 with 50 Hertz behaves. Goes 219. Well, I'll take it. Okay, so if you have ever designed or seen a power supply circuit, you know you have to have a bridge rectifier made out of 4 diodes. I'm not gonna explain much on that, but we can just go already and place one ourselves. We search diode and we can place the bridge rectifier right about here. Now these are standing upright, so I'm just gonna rotate them. Connect the 4 diodes. Just make it more presentable as well. Now, again to the basic diagram of a power supply. You know you need a capacitor. You're gonna need a capacitor for the ripple effect and blah blah blah. That's common knowledge already. I'm just going to show you how to design it. I'm gonna put the capacitor here, and you know how that works in a power supply. You should be knowing. And now I'm gonna design this to power a 5-volt charger, like a phone charger. So instead of going for the LM anything, I'm just gonna go straight for a Zener diode, which is the simplest way to go about this. I'm gonna put a 5.1 volt Zener diode into the circuit. And I'm gonna turn it up right. There we go. So I'm gonna go back and connect the circuit how it's typically connected. We have the ground wire that goes all underneath the components connecting them all. There we go. Then we have the VCC for the DC voltage that's going to come out of the bridge rectifier, connected to the components from above. Then a typical circuit, we just connect these straight to the AC and the ground one to the AC as well. Now usually we're going to have a transformer right in between the two, the AC and the bridge rectifier, but we're designing a transformerless one. So here's how we're going to go about it. Now if I connect a capacitor and a resistor in parallel and connect it between the two, it should drop down the AC voltage theoretically. I haven't tried it out yet, but the schematic shows it works. So I'm just going to place a capacitor here I'm gonna try and rotate that. Yeah, we're gonna have to get rid of the whole wire. Yeah, there we go. Then we introduce a resistor into the circuit right above the capacitor. Then we connect these two in parallel, positive to positive, negative to negative. Then we just join the two circuits from the AC and the bridge rectifier. There we go. Then we're going to introduce a small extra component right here, a resistor. Nope. Yeah, there we go. We're going to introduce a resistor there. Now from here, yeah, this is a typical circuit. I think I'm gonna have to introduce a DC voltmeter at the end of it to show you the output voltage. So yeah, typical connections, positive to positive, negative to negative. Little circuit diagnosis. Oh, the smaller the capacitor value, the lesser the ripple effect. So I'm gonna increase this, put it up to 470 microfarads. And yeah, this looks pretty good. Let's run it. And there we go. We're taking it from 220 to right about 5 volts. The circuit doesn't have a transformer. We have a bridge rectifier, we have a capacitor, and a Zener diode. Yeah, I think that's it. Thank you so much for watching. I'll catch you on the next one. Bye.